Hello, everybody, and welcome to the June 7th, 2022 iteration of the Kubernetes SIG Windows community meeting. As always, these meetings are recorded and uploaded to YouTube, so be sure to adhere to the CNCF Code of Conduct, which pretty much boils down to be respectful and nice to everybody. Let's get started with some of the agenda announcements. First announcement is that enhancement freeze for the 125 release is next Thursday. This enhancement freeze is kind of, I think it's earlier in the release and also feels earlier because of the delay to the 124 release too. So if anybody's working on any caps, just keep that in mind. I think most of the actions I need to finish some reviews now though. Next announcement is some of the big doc restructuring PRs have merged. I encourage folks to take a look and see if there's any comments or feedback on them. There's a couple of PRs linked in the issue here if you are interested in the PRs. If not, just go to the Kubernetes website and see if all the Windows information is where you're expecting. Does anybody have anything else to announce? Not. Okay, now I think we can we'll give some space if there's anybody who's new to the call and wants to introduce themselves or ask any brief questions or just say hi. I see a couple of new folks, but no pressure if you don't want to say hi. Okay, get into the agenda. First agenda item is a couple of weeks ago, I think some folks were asking about some Windows ARM container announcements from Build. I think we've got Rich on the call who can provide a little bit more information. Do you want to say hi, Rich? And is there anything you want to share?
Hi, folks. Thanks for the opportunity to come and meet with you and discuss. We made a bunch of announcements last week at Build, announcing a ton of stuff that we've been working on for the last 18 months and actually for much longer, but in particular for the last 18 months that I'll be giving you a summary of this morning or this afternoon, depending on where you are. And hopefully it will give you some good perspective and an overview of a ton of work that we're doing to really light up Windows for ARM developers. This is broader than the just container and just cloud story. It's for the all up story. So it will be relevant to many of you in many scenarios, I hope. So yeah, happy to take you through that.
Yeah, did you have anything you wanted to share or present, or does anybody have any specific questions?
I have brought a deck with me. If that works for you, I can share that up.
Yeah, let me stop my screen share so you can get the whole screen. And then let me know if you should have access to share, but let me know if you don't.
Let's see. It should work. Let me know if you can all see this.
I can see that.
Excellent. Okay, so this is a relatively short deck. I'll try to summarize down all of the announcements that we made last week, but also give you some perspective and some background as to why we've done all of this work, what it is that we're actually up to, why we've gone through all this effort, and what we're aiming to enable by doing so. So I'll spin through. If anyone has any questions, I'm not sure I'll be able to see questions during. So if you wouldn't mind holding questions to the end, I'm hoping to get through with plenty of time for lots of questions and stuff afterwards if anyone has them. And feel free to interrupt me at any point if there's anything I need to pause for. Okay, so Project Wilson is the code name for a project I started running about 18 months ago now. It's not Wilson, the bull from the Tom Hanks movie. It's named after Sophie Wilson, who created the ARM instruction set along with Steve Ferber back in 1985. I first used my first ever ARM-powered computer back in 1987 with the Acorn Archimedes, when the rest of the world was still largely 8-bit, or at least non-business world. Most schools and stuff were running 8-bit computers. 16-bit was just emerging with the Amiga and the Atari ST, and then along comes this crazy device from a crazy British company that said it was going to build this RISC processor, and we all said, what on earth is that? ARM since then has flourished and gone from strength to strength, and now is becoming highly interesting and available on multiple platforms and in multiple scenarios, not just embedded and mobile devices where they started, but is starting to become very viable for desktop and server as well. So this has started to get quite a lot of attention. And it's important to state because we have there's another player in the industry who is also making very big strides into ARM. Apple is investing huge amounts right now in moving their entire ecosystem to ARM. I just want to make it absolutely clear, we have no intentions of lifting and shifting the entire Windows and Microsoft ecosystem to natively and solely target ARM. So x64 remains a very important part of our ecosystem. x64 still has many, many, many benefits. Its power and performance, power in terms of performance in particular is pretty unrivaled. But we have to be keeping our eye on merging technologies, and Windows has always done this. You know, we've always evolved Windows. Way back when there were multiple CPU vendors and we didn't know which way the industry was going to go. Windows used to run on DEC Alphas and MIPS R3000 and PowerPC and all kinds of processors back in the early days of Windows NT in particular. But x64 beat most of the others out of the market. The emerging technologies, however, that we're seeing today is ARM. ARM has, as I mentioned, gone from a very interesting RISC processor back in the 80s to running practically every smartphone, every tablet, every fridge, TV, many, many embedded devices, network routers, switches, Wi-Fi boxes that I've got up on the shelf behind me here. ARM processors in particular offer great performance, especially when you compare performance per watt. This is a point I made in my breakout session at Build this week, which you can now find on YouTube as well. I can share the link later on if you're interested. The power performance curve is quite incredible for ARM. Apple's announcements yesterday of M2 show some very interesting charts as well, especially comparing with an Intel-powered Mac. What the M2 can deliver. So the power and performance capabilities of ARM are very, very interesting indeed. And the depth of integration of all the componentry that you would normally find in discrete chips on a motherboard, the number of those components that are now being integrated into the core system on chip, or SoC, as we know of it today, is really quite interesting, because that also makes ARM-powered devices much smaller, or enables them to be much smaller, or to be designed with much more interesting form factors and different footprints, larger battery space available within the device itself to power a device that's already battery frugal, will mean that we'll start seeing ARM devices lasting multiple days on a single charge, which will be very exciting for many who are used to laptops that last 3, 4, 5 hours, if you're lucky, on a single charge today. So this is an area we're extremely interested in. Microsoft started its foray into running real Windows on ARM back in the 2011-12 timeframe, when we first launched Surface RT. That was very, very early in the ARM days. However, ARM was still very, very new on anything other than embedded and portable devices. And over the years, we've continued to work with ARM and many of our ARM partners to improve the ARM hardware, while also making our software better, making Windows itself, for example, fully support ARM across the board. But we need to do more, and we know that. This is something that we've been gestating for quite a while. So in Windows 10, we reintroduced ARM support in 2019, when we introduced the Surface Pro X, which was our first ARM-powered device since Surface RT. And the Pro X, which, funnily enough, I daily drive and is sitting here on the desk next to me. It's a beautiful, slim little device with a kickstand, if you like that form factor. Great device, but it could do with having more ARM native applications running on it. We'll talk about that in just a minute. Along with Surface RT, we also introduced x86 emulation capability in Windows 10, which allows an ARM-powered, for example, Surface Pro X or ARM-powered device from some of our OEM partners to run unmodified x86 applications on an ARM device. There is a perf hit there. There is a certain amount of battery consumption there, but at least it means that if you have applications that haven't yet been ported natively to ARM, they can and will run by and large on the device. In Windows 11 that we launched last November, we introduced x64 emulation as well. So you can now run both x86 and x64 unmodified Windows apps on a Surface Pro X, for example, which is very, very powerful and very, very cool. But in order to take full advantage of the benefits of ARM, in particular power consumption, its performance capabilities, and many of the features that are embedded into an ARM-powered device, you really need ARM native applications. You want applications that are built to natively target and execute on that machine as efficiently, as effectively, and as quickly as possible. So in order to do that, we're going to need to give the Windows developers a decent suite of tools, services, and devices upon which to build native Windows applications that target ARM. The developers will need IDEs, the tools, runtimes, frameworks, libraries they need in order to build their applications will all need to be ported to run natively on ARM as well. Developers also these days are highly dependent on services like CI/CD infrastructure in Azure DevOps and GitHub and elsewhere. And of course, developers need VMs and containers in which to house their running services if they want to take advantage of running ARM in the cloud as well, which, funnily enough, is something that the Azure team just announced the first preview of their new ARM 64 VMs just a few weeks before build. And at build, they also announced ARM containers will be coming very soon as well. And we're working in close partnership with our friends over in the Azure team to help make sure that what we're building helps them and what they're building helps us and helps everyone else, therefore, as well. So very exciting stuff coming to the cloud. But developers also tell us vociferously that they want new devices. They want new devices in different form factors, and they want devices that they can build and run all of their applications on all day long. Developers typically don't much enjoy the having to build an application on a PC, then push the built binaries over to a target device, and then set up remote debugging, and hopefully get the two devices to talk to each other. And it's a lot of fuss and bother when they much prefer running all their dev tools and have all their code and words so they can read the specs, because of course all developers build code to well-written specs, of course. And spreadsheets and mail clients and Zoom chat clients and all kinds of things. They want to run all of this stuff on the same device side by side without having to separately target a separate device upon which they run and debug their built applications. Now, this was a perspective that was born from lots of conversations with partners and with our own teams as well, because of course we have teams building software for Mac and Linux and Windows and Mac and all kinds of things as well. So we also, however, reached out to our developer community. And in this link in the bottom right corner, you'll be able to go and read a fascinating thread of some 360 odd responses now on the Visual Studio discussion forum, where we asked the question, would the developer community be interested in Visual Studio being made available as a native ARM build itself? And the conversation there has been absolutely fascinating. An awful lot of it has also backed up many of our assumptions and many of the assertions that we'd heard through conversations with customers and partners and so on as well, which was extremely gratifying. I've been engaging in this thread now for the last year or so, and it's been hugely illuminating, and enormous thanks to everybody who's pitched in and shared their experiences, their asks, their wants and needs to this thread. It's been really, really interesting and fascinating stuff that we've learned from that. So thank you to everyone who's piled in. And so using all of that feedback, we've essentially started driving an effort to help improve the Windows developers' lot. One of those things we mentioned was that a lot of developers want better hardware. And we'll come back to hardware in a bit more detail. But typically, when looking at ARM devices that developers have available to them up until very, very recently, many ARM devices were seen as being relatively low power, relatively low performance. They generally didn't have enough memory, they didn't have enough ports, they didn't have physical Ethernet, for example, which a lot of developers who, especially in desktop environments, need in order to be able to connect up to corporate networks and have high bandwidth data exchange, et cetera, with their, for example, when copying media back and forth onto their build machines. And really those devices, a lot of these devices, while great for portable scenarios, and I've been daily driving this thing for the last couple of years now, I actually built chunks of Windows Terminal, which I previously ran on this very device. They're not very good for lab scenarios. So stacking and racking these things 50 deep for your own CI/CD, for your own build infrastructure, for your own test infrastructure, is a relatively costly and complex process, especially considering there's no physical Ethernet in these things, for example. They carry screens why do you need screens on devices that are stuck in racks, et cetera, et cetera. So developers, of course, want the fastest devices they can possibly get their hands on at certain price points, or at different price points, I should say. They want more memory, they want faster storage, they want to connect up multiple 4K external displays, they want to connect up their mechanical keyboards and their mice and all kinds of other bits and pieces, so that they have a single environment in which to be productive. And we completely agree with that. So the Project Wilson was essentially an effort to bring all of this and pull all of these threads together and to deliver a coherent story for developers on Windows. And it starts with the platform. So we want a native ARM platform. We've got a good story there with Windows already, but we also need tools and services and devices. So with the OS and platform, we wanted to make sure that Windows 11 was fully supporting ARM across the board. And there aren't, I think, any features of Windows 11 now that don't work on ARM itself. We also made sure that the Windows Terminal worked great on ARM. From the very first day when we started the Windows Terminal project, I banged the desk and said, right, we've got to make sure this works on ARM as well. And everyone said, why? No one uses ARM right now. And we said, yes, but they will. And thank goodness we did, because they are. The Windows Terminal, of course, is the Windows command line experience, the new modern Windows command line experience, which, if you're also a Linux fan, is a great place in which to run Linux apps and tools. And we wanted to make sure that WSL, therefore, ran on ARM as well. And so we worked with our friends at Ubuntu and with SUSE and various other distro vendors to make sure that they were shipping ARM versions of their distros for WSL as well. We worked with Hyper-V and Docker as well to make sure that Hyper-V and Docker containers and our Windows container infrastructure also supported ARM, as does the WinApp SDK, which is the new modern Windows application development platform for native and modern Windows applications, as well as things like PowerToys also support ARM. So Clint Rutkus, that's been running PowerToys for the last couple of years, he and I were actually office mates until we were sent home to work from home because of COVID. And he regularly beats me up for devices and finding issues, and we go and solve those issues, which now enables all of PowerToys to run natively on ARM as well. A great place to go and explore, because it's all open source, what it's taken them, for example, to port a quite complex suite of apps and tools to natively target ARM. So it's a great place to go and discover how they did it, so you can as well. We also made sure that we work with Visual Studio. So we've been working with our friends in VS, in Visual C++, in modern.NET. We also are bringing legacy or classic .NET Framework 4.8 to ARM as well, so that you have, if you have, for example, large numbers of enterprise or commercial applications that have been built using .NET Framework over the years, that you should have a fairly trivial process of porting those applications to run on ARM too. VS Code, because it's built on Electron, along with Microsoft Teams, have actually been supporting ARM for quite a while now, because Electron ported support or added support for ARM a couple of years ago. So they've been available for a while. But we're also reaching out, doing a ton of work with a bunch of open source projects, including Java, because Microsoft now has an OpenJDK team, which is great. But we also work with Python and with Node and with Git and Clang and LLVM and a whole host of other projects. We're leaning in and helping and supporting those projects, providing some resources via a partnership with Linaro, which was a spin-off from ARM itself that's being sponsored by ourselves and ARM and Qualcomm, and others are joining as well in an effort to help port the larger body of open source projects to natively target Windows on ARM as well. So extremely exciting stuff there. Obviously, this will take some time to happen, but hopefully as the ball starts rolling and more of this stuff starts getting converted, more and more people start leaning in and helping out with their small corner of the open source ecosystem and helping all of us benefit from seeing all this stuff natively targeting ARM as well. We also have been working with our friends in Azure and with GitHub to figure out what our plan is and what our path is to enabling ARM CI/CD offered by Azure DevOps and GitHub to become a reality. We've been working with the Azure compute team to help make sure that they're able to build ARM VMs in the sky that then fuel ARM containers, that then fuel GitHub build actions and Azure pipelines as well. So that story is unfolding. We will be publishing information later this summer about the timeframes and a roadmap for getting Azure and GitHub to support full ARM-based CI/CD as well, so that you'll be able to build and execute the tests for your applications on ARM hardware up in the sky. Windows Store as well, sorry, the Microsoft Store, I should say. We've also been working with over the last few months because they're preparing to start ingesting a lot more ARM-based applications into the Microsoft Store. The Microsoft Store itself has had a massive overhaul over the last 18 months or so, and it's great to see some really powerful capabilities coming to the Microsoft Store. If anyone's interested in distributing Windows applications to a large number of people as easily and effectively as possible, there are a bunch of announcements at Build this year. I encourage you to go and watch the store sessions in particular. There's some really exciting stuff coming there, giving you much more flexibility over how you actually distribute your apps, even if you publish them via the store itself. So great stuff to go and take a look at. And of course, as we mentioned, devices. So we have Surface Pro X today. Lenovo are coming out with the ThinkPad X13s very soon. And I know that a bunch of other OEMs are also working on ARM-based devices. So keep your eyes peeled in the next year or so, and you should see more and more devices coming down the pipe as well. We are also and have announced at Build the prototype AI toolchain in Azure ML. Awesome product name, but we had to scramble for a name right at the very end of the planning process. So we'll see what the name actually ends up being by the time we go live with this. But we started essentially explaining our vision, multi-year vision. It's going to take a while to land some of it, but our multi-year vision for enabling developers to build applications that take advantage of AI and ML, even if the end user who's running those applications might be running a device that doesn't have any AI and ML accelerating hardware on the device itself. So being able to execute some of that code up in the cloud, for example, is going to be super interesting. But we also announced something called Project Volterra. And yes, we're announcing this stuff at Build, and we're aiming to get the majority of the stuff that you see on the chart here GA by the end of the calendar year. This won't be the end of this effort. This will take a few years to land this whole expansive effort because, of course, the open source community and all of the open source tools that people use these days is enormous. And so that will take some time to gestate out. And we'll obviously be making improvements along the way. But we're going to try and get as much of this landed by end of this calendar year as possible. So Project Volterra is the code name for a new device that we're working upon. It is a device that was built by Windows developers for Windows developers. It was specifically designed for developers and in fact isn't going to be available in the retail channel for end users to run, because this is a device specifically to enable developers to build and test and debug and get their applications ported to ARM and then distributed for end users to run on Pro X's and Lenovo devices and devices coming from OEM partners later. These devices are specifically built with the features that most developers have communicated to us. It will be more than able to handle the Windows application developers' workloads and tools with ease. We don't want you to fire up Visual Studio and suddenly the whole thing comes crawling to a halt because you've got a massive project. We want this thing to actually work all day long for the vast majority of developers. It comes in a slimline desktop form factor, which looks great on your desk. It's down here. I've got a pre-production version on my desk right here, which I unfortunately can't show you, but you'll see a rendering of what the device should look like in just a second. In fact, I'll tell you that this presentation that I'm projecting here is actually being run on a Volterra device. So you're actually being presented to by an ARM-powered Volterra right now.
Rich, yeah, sorry to interrupt, but we've only got about 4 minutes left in this community meeting. So I was wondering if we could, if you had anything to wrap up, and maybe I think some folks would want to ask some questions.
Right, so I have one slide left after this one, which was the sizzle video from Build. It's about 1.5 minutes long. Happy to pause that and not show it if you like, and go to questions instead, because you can go and see the Build video if you like. And I'm happy to send the link to
we can link it
on their own.
We can link it in the agenda. I think it might be good to ask some questions.
Great, happy to.
I've got some questions that I'll start off with. So this audience is the Kubernetes community, primarily focused on containers and Windows Server support. I was wondering, I know there was a lot of talk about Windows 11 support. How much of this is in Windows Server 2025, and what kind of support can we see for ARM, especially containers coming in the future?
So that's a great question, and it's something that we're still trying to tease out right now. So I will share that right now, the primary focus has been to get this into the hands of developers, which most developers these days run Windows 11 or Windows desktop OSs. And so we're most interested in getting this into the hands of Windows developers so that they can do their development work, their testing work, debugging, getting things working, and so on and so on. It's a really interesting time in the industry to see things like, for example, Azure hosting ARM infrastructure, in which you can run large scale VMs, or tiny VMs all the way up to scale VMs. They have many offerings available in that space. One of the challenges with ARM right now is, if you wanted to run it on a Windows server, where are you going to get an ARM server from? There aren't that many vendors who are offering physical ARM server hardware. There are some, certainly. We've been partnering with some to build our own Azure infrastructure. There aren't that many, however, vendors who are offering commercially supported, fully engineered server infrastructure upon which, ARM infrastructure, upon which to run server, even if you wanted to. You could, in theory, I mean, a Volterra device runs Windows 11, and if you can run Windows 11, chances are you can run Windows Server on it as well. But I don't have details right now of what the server story looks like, and so we'll be working on figuring out what that looks like and publishing more information later in the year. But when it comes to running containers in, for example, Azure Kubernetes services, then yes, that will all be supported. The Azure team are readying their first preview of that capability now. You can already run VMs in their initial preview. They're working on getting VMs to GA as soon as possible, and also now opening up the container services so that you can use AKS to deploy your container workloads, running either Windows or Linux workloads within them. So we are just as keen to make this work for Windows as we do for Linux, and so we're trying to provide you as broad a capability set there as possible.
I know you mentioned Windows RT. I still have a Windows RT device. I thought it was.
I still have one down here, yeah.
But I can't find mine. But I know I still have it.
Yes, it was a fascinating time in the history of this story.
I need to drop for another meeting in about a minute, but I'm going to open it up to see if there's anybody else on the call who has some more specific questions. I think Jamie, who is particularly interested in the ARM story for servers, not here, but some other folks do. Yeah, and also
what I will say is, if anyone has questions, feel free to reach out to us. We are working on plans to begin building a community around this, because we can't do this in isolation, right? We can only do so much as Microsoft. So we're working on opening up a blog mechanism so that we have a way of communicating and sharing new status updates and interesting things in this space, specifically around ARM itself, and also potentially opening up a GitHub repo where we can accept feedback and log and track issues and share plans, goals, roadmaps, timelines, all that kind of stuff. So we'd love to have as many of you participating in that forum as you like, and it would be great to see many of you there.
Yeah, yeah. I think there's a lot of folks from other companies here I think there's representation from VMware, Amazon, and a few others too who might
Right.
be interested.
Yeah, absolutely.
Yeah. Yeah, I do need to drop for another meeting, Jay. I'm going to make you the host, and feel free to ask other questions. I do want to say thank you, Marguerite, for listening in the community meeting 2 weeks ago and then connecting us with Rich.
Anytime. Thank you, guys. Thank you, Rich.
Yeah.
Awesome. We can stop sharing as well.
Yeah, I'm going to hand it over to Jay then.
Hey, folks. Yeah. I know me and Amim and Dimitri, we're going to talk about, no problem, James, KPNG stuff, and where we're at. We're looking at 2 different routes to go for it. So maybe doing both at the same time. And so welcome back, Dimitri. It's good to have you back. And Amim, Dimitri, what do you think we should do? Do you think we should just build both? I'm okay with building both. I mean, like that was something you proposed the other day, like building the and oh, by the way, for folks, I know Rich and other folks are here. KPNG is the next generation kube proxy we're building with a much lighter weight kube proxy for Win, and it's specifically excited on the Windows side because it'll be less sort of dependency on the Windows server to Kubernetes, and so it'll let less CPU, and who knows, maybe even plays in with this ARM stuff, because once you're using ARM, you can run smaller devices and things like that. So yeah, anyways, so KPNG next gen kube proxy, trying to make the kube proxy leaner for Windows, easier to distribute, decouple, and there's a way to build it which is extremely lean, or there's a way we can do it in KPNG where it's still lean, but not as lean, where we borrow all of the old legacy functionality. And Dimitri's kind of helping me to finish the legacy implementation, but there's a implementation sort of shortcut that we do where we copy paste the old kube proxy in and we get it working in the new KPNG environment. So we're kind of working on parallel threads right now. And I don't know, what are y'all thinking about that? I don't know if you all synced up yet or what.
So yeah, what we agree is that Dimitri will continue what he's doing. That's finishing and delivering this.
Mm-hmm.
And in parallel, work in the full state and see if this makes sense. But like, just as a POC, then
Yeah.
Yes, I think getting it as in an initial working state on Windows, that would be great, and we can make more iterations afterwards.
Yeah, I like that idea. That keeps us on the critical path. So I know it'll probably take you a couple of days just to get back in the swing of things and everything, Dimitri, and that's fine. Just let us know if you get stuck on anything.
Yes. Amim has been very kind to me.
Cool.
So I can bother or poke him.
Cool. Awesome. I think that's all I got.
Jay pays the barbecue.
Yeah, I'll just pay for hamburger. I'll just buy you hamburgers for everybody. I mean, I think that's it. I mean, I think we all know what to do. We've got enough of a road in front of us that we don't need to have a long meeting about it. So that's pretty much all I got. Anything else?
Same. Not from me.
I see Friedrich is here. Friedrich, she decided to show up because, you know, we got 5 more stars on SIG Windows Dev Tools. So.
I have a question. So there's this discussion that I just saw. I overlooked it. Zappa told me about it. Like there's a new cap being written up, or
Yes.
KPNG effort. Is that like Dan requested it, I think, or something?
Yes.
Is the right forum to stay on track on and the loop of that to attend the meeting on Friday? Is that like a weekly meeting? The KPNG meetups?
You could stay up to update on the KEP, but you're already right in the middle of it because Dimitri is there's nothing Dimitri won't know. Like the biggest part of the KEP is going to be just the formal aspects of getting it finished and getting it merged. And so yes, absolutely. Like I'm here every week and I'm happy to give KEP updates. But I think that's more like paperwork kind of at this point, you know, because you and me have been working on it already, right, David? Like we've talked so much about it that you know where everything's headed, right? And the KEP is just a matter of doing all the TPS reports so that we're allowed to finish what we've already kind of created. You know what I mean?
Yeah, right.
It's just
Yeah, I understand
TPS
that.
reports. So you and me and Dimitri and Amim are all talking and getting it. You're way ahead of all that. Yeah. Mike did volunteer to help us finish the KEP, which is cool. And that's just a matter of babysitting and being present and answering comments quickly and shaking hands and kissing babies and stuff like that, you know.
Yeah, right. Okay. Okay, cool. Thanks.
I really love KEPs. If you can't, I was like, when Dan told me we had to do a KEP, I was like, I don't know, please don't make us do a KEP. I'm like, come on, like, but yeah, they're making us do a KEP. But yeah, so yeah, but no, we'll do it. We got it. Rajas is going to own that whole process. If you want to get more involved in it, which I would encourage, because the more involved other people are, the less involved I have to be in that. The Rajas Kakadar is going to own finishing the KEP. And so he is one of the people that helps us run the kube proxy working group. And so he's going to own finishing the KEP, and the authors on the KEP are basically going to be everybody who's involved in any of the KPNG backends. So like me, Amim, Rajas, Neha, Anusha, obviously Mikhail, you know, he wrote the original thing. You know, anybody who's owning any piece of KPNG is just going to be an author on there. So Friedrich, you can be an author on the KEP too if you want to help us out. Because I don't know if you still own the CI, but somebody needs to own the CI still and the build infrastructure and all that. But yeah, so there's a HackMD. Mike Zappa has access to the HackMD. And if anybody wants to jump in there and add stuff to the HackMD, just go for it and add your name as an author on there.
All right, I pasted it in chat. Hopefully I
Yeah,
got
there
the
you
right
go.
one.
Yeah.
Cool.
So that's
All right,
it. Once we
thanks.
get the Windows backend in, we will have everything we want in that KEP to be able to say we're ready to go live with this, right? Because at that point, the biggest things we need are the Windows kernel space, and we've got folks working on that, and then the Linux IP tables kernel space, and that's really, we're just in that last 10% slog, and it's probably going to take us another 2 months just to finish really hammering out the last few contract related issues in there. But you know, then at that point, I think it's pretty easy for us to merge the KEP and move forward with it. I mean, we could even probably merge the KEP before all of that, you know, but it's nice that we have all these backends working, because as Dan said, you know, he's like, it's pretty hard to argue with working code, you know, so we kind of did everything backwards. We wrote all the code first, and now we're making the plan for what we're doing the plan now. So, you know. That's all I got. Claudio, you got any jokes for us before we drop?
I actually do. Last night I went to a dessert store and I asked if they still serve the dessert of the day, but they said no because it's already night.
Oh, that's just Jesus.
Sorry.
That's me. Yeah, that might be the worst one that you've ever told us. That might be the worst joke you've ever come up. Wow. Damn, Claudio.
I don't think you should say that because I'm gonna come next time with an even worse joke.
You things can always get worse, right?
Yeah.
It's the definition of hell in every religion. Things can always get worse. Oh man. All right, I gotta go. I'm at a VMware offsite. So but yeah. Hey Friedrich, if you want to get back involved in some stuff, feel free to ping us. You know, we're around. We're doing a new push on SIG Windows Dev Tools, by the way, to sort of harden it a little bit and make it a little more usable. It's post KubeCon because we've got new people looking at it and stuff. And so one of the things I'm doing is testing, really trying to get the Antria parts working. And because it looks like Antria broke. And I guess before we drop a meme, do you remember where we're at with that? Because I know you mentioned something, and then I mentioned something, and then we merged the SSL fix.
That SSL version doesn't have the required libraries. We probably
Okay.
need the old exe. I don't think we can get the old exe, but we need. There are like 32 DLLs that
Okay.
are missing.
Okay, cool. Got it. Okay, great. All right. So now that you told me that, I'll remember it and I'll start working on that. And I'll probably just figure out a way to, maybe I could just copy something from downstream, like somehow maybe we've got an exe that's floating around downstream that we can just put up on a bucket somewhere.
Just don't get fired for this.
Yeah, I mean, before I do that, I'll make sure that I don't. This meeting's being recorded. All right, awesome. Cool. We'll see you all in a little bit.
Right, see.